Welcome back, dear students. This is Ramana sir, Physics. The last class we discussed the IP final examinations, the important long answers we are discussing. So these are useful for improvement and supplementary students also. By easy method we are discussing along with attachment questions. Already simple pendulum, simple harmonic motion long answers were given in description. So you can go through that. And in this class we'll discuss work energy power lesson. In this lesson we are having three LAQs. The first one is the most important one, law of conservation of energy in case of freely falling body, statement and proof, and collision topic also there, and work energy theorem. There are three long answers are there. In this class we will discuss that three LAQs along with attachment problems we'll discuss. Okay, shall we start? Now the last question, state and prove law of conservation of energy in case of freely falling body. In case of freely falling body. Statement we have to write first. So then explanation, the need diagram we have to draw. Then after that explanation, own matter you can write the explanation. I'll give the matter. Then the equations, the derivation we have to derive. How to derive? By easy method I'll discuss in this class. First of all, statement, law of conservation of energy. So what is law of conservation of energy? The statement is what? Here the energy can neither be created nor be destroyed, but total energy in the universe remains constant. So this is called law of conservation of energy. Example, for example, solar energy is converting into the electrical energy. Again, that electrical energy is converting into the light energy. Here one form of energy is converting into another form. So but total energy in the universe remains constant. Here for in case of freely falling body, they are asking prove this in case of freely falling body. For example, so one block is I am dropping from certain height. One block is dropping from certain height. At highest point, here initial velocity and final velocities are zero. So that time it consists only potential energy. There is no motion in the body. That is why it consists only potential energy. There is no kinetic energy. Kinetic energy consists only when bodies are in motion. Okay, here the body consists only potential energy at starting initial point. Whenever the body is released at the middle point, what happens? It consists both kinetic energy and potential energy. Both it consists. So that time also we have to show that total energy remains constant. Total energy means here kinetic energy plus potential energy. Total energy means kinetic energy plus potential energy. Then after reaching the ground, the body consists only kinetic energy. So no potential energy. Why? Because there is no height, no gravity on the body. So there is no height, there is no potential energy. Total energy is what? That equal to kinetic energy only. Here also we have to show that total energy remains constant at A point, at B point and C point. At 3 points we have to prove that total energy remains constant. Statement is what? So on display also I am giving. So you can check. Energy can neither be created nor be destroyed. Total energy in the universe remains constant. That means one form of energy converting into another form, but total energy in the universe remains constant. That is called law of conservation of energy. First statement you have to write. Okay, so here total energy, what we are saying, total energy means kinetic energy plus potential energy. Total energy is what? Kinetic energy plus potential energy. After the statement, proof. In proof, just the 2-3 lines introduction of the topic you have to write. How to write introduction? Listen here. Consider a body of mass m. So that is body is allowed to fall freely from certain height from the ground. So then the body position at A point, B point, C point, total energies you have to calculate. Very simple matter you have to write. consider a body of mass m is allowed to fall freely from certain height h from the ground. Then the body position at A point, B point, C point, total energy we have to calculate. First of all, at A point, the body is at height h. So that is why. So what we can take? Okay, height is h we are taking. Initial velocity u and final velocity v also 0. Why? Because body at rest. Body at rest, we are not released. Body at rest at A point. So that is why. What happened that time? Initial velocity, final velocity is 0. Here, kinetic energy. What is the formula? Kinetic energy formula is what? Half mv square. Here, initial and final velocities are zeros only. So that is why substitute here 0. Kinetic energy equal to what? Half m into v square. This 0 square. Here 0 into something is what? 0. Therefore, kinetic energy is 0. We'll see potential energy. But potential energy Pe equal to mg into height. So that height is what? H, mg h. Therefore, total energy formula is what? Kinetic energy plus potential energy. Total energy is equal to kinetic energy is what? 0. Potential energy is what? mg h. Therefore, total energy at point A is equal to how much? mg h. So I am writing in one box this total energy mgh at point A. Now we'll see at point B. Now the body is released. The body traveled at x displacement. Now the body is travel from A point to B point. So traveling displacement is what? At x displacement. Now the body height is how much? H minus x. The body height is h minus x. Okay. Now we'll write body initial velocity u is what? At point B. Initial velocity of the body is what? U equal to 0. The final velocity v will take vb will take, and traveling displacement s equal to what? X. Traveling displacement s equal to x, and the height body at h minus x height. Okay, from formula equations of motion, there are 4 equations are there. So in that I am taking v square minus u square equal to 2as formula. I am taking v square minus u square equal to 2as formula. In this I am substituting the values. Vb square minus 0 square is equal to 2a is what? G I am taking. Why? Because body is falling freely. For freely falling body purpose, acceleration is what? Plus g. So that is g I am taking. And traveling displacement is how much? X. Now Vb square is equal to 2gx. Vb square equal to what? 2gx. Now kinetic energy at B point. What is the formula? Kinetic energy at B point of mv square. V square means at B point. Here Vb square value substitute 2gx. Kinetic energy equal to half m. Vb square is what? 2gx. Here 2 gets cancelled. Kinetic energy equal to what? mgx. Kinetic energy is what? mgx. Now potential energy. Now body is at height. Okay. Now body at h minus x height. What is the height? Body is at h minus x height. Body is at h minus x height. That is why potential energy is what? mg into h minus x I am taking. mg into h minus x. Why? Because the body height is how much? H minus x. Here open this bracket. Potential energy is equal to mgh minus mgx. Therefore total energy is what? Total energy is equal to, we know that, kinetic energy plus potential energy. Kinetic energy plus potential energy. Therefore total energy is equal to, substitute the values. Kinetic energy is how much? mgx. And potential energy is how much? mgh minus mgx. mgh minus mgx. Here plus mgx minus mgx cancel. Therefore, total energy at B point is how much? mgh. At B point also we got mgh we got. Now finally at C point also we have to show that mgh. Okay. Now at point C, here freely falling body is touched on the ground. Here body at C point means body is falling freely. So that is why initial velocity u is what? 0. The final velocity v equal to at C point whatever the final velocity. So that at C point vc I am taking, and body is moving downward. That is why acceleration I am taking plus g I am taking, and the body displacement, how much displacement from A point to C point, how much displaced? H distance traveled from A point to C point. Okay, here substitute from v square minus u square equal to 2as formula. V square, v is what? Final velocity vc at point C, minus 0 square is equal to 2g into h. Here v square equal to what? 2gh. Substitute in kinetic energy formula. Kinetic energy equal to, what is the formula? Half mv square. Here v means what? Vc I am taking. Here kinetic energy equal to half m vc square. Vc square is what? Vc square is 2gh. 2 gets cancelled. Therefore kinetic energy equal to mgh. Kinetic energy equal to what? mgh. Potential energy. Now body at on ground. Therefore the height is 0. There is no height. Height is 0. Height is 0. That is why potential energy is what? 0. Therefore potential energy is what? Potential energy is what? 0. Okay. Therefore total energy is equal to kinetic energy plus potential energy. Substitute the values. Total energy equal to kinetic energy, how much we got? mgh. And potential energy, how much we got? 0. Therefore total energy at point C is equal to how much? mgh. Total energy at point C is what? mgh. So at A point mgh, and B point also mgh, and C point also mgh. We proved in case of freely falling body law of conservation of energy. Therefore final conclusion you have to write. Okay, from A, B, C points, A, B, C points, it is very clear what? Total energy at point A is equal to total energy at point B is equal to total energy at point C. So what to write? Therefore law of conservation of energy proved. So this is the most important question in TS and AP final examination long answer. Okay, so next question we'll discuss. Afterwards attachment problems also we'll discuss in the class. This is the law of conservation of energy in case of freely falling body. Most important to answer this one for TS and AP intermediate first year final examination or improvement or supplementary purpose. Most important attachments, sometimes they'll ask the problem also. After discussing the next two questions, I'll explain attachment problems also. The next one, state and prove work energy theorem. The last question. So in this, first they'll ask the definitions of work and kinetic energy. Then they'll ask prove that work energy theorem. So in this, first we have to define work definition and kinetic energy definition. Then we have to prove the work energy theorem. Here work definition is what? The work is the product of magnitude of force and displacement, and along the direction of displacement is called work. We can denote this one symbol W. W equal to what? F bar dot S bar. we can write Fs cos theta also we can write, that is work. The work unit is what? What is the unit of work? SI unit is what? SI unit of work is what? Joule. Symbol J. Joule symbol J. Next, kinetic energy. So what is kinetic energy? Kinetic energy is what? Here we discussed in the previous question kinetic energy and potential energy. Kinetic energy means the body should in motion. Here energy passed by the body by virtue of its motion is called kinetic energy. Kinetic energy formula Ke equal to what? Kinetic energy equal to what? Half mv square. Half mv square. Okay, first of all, you have to write these definitions. After writing the definitions, okay, unit also formula you have to write. Then unit SI unit of kinetic energy is what? Same as that of work only. So that is joule. Okay, so symbol what? J. Now work energy theorem. So what is work energy theorem? Okay, highlight the statement. Work energy theorem statement is in here. Statement of work energy theorem. So what we can write? The change in kinetic energy on a particle is equal to the work done by the net force. Here the work energy theorem statement is what? The change in kinetic energy is equal to the work done on it by the net force. According to definition, so we can write the formula. So that is what? So that is what we can write, the change in kinetic energy, what? Kinetic energy final minus kinetic energy initial is equal to what? W. So this equation now we have to prove. Here in proof, so consider a body of mass m. Own matter you can write along with the diagram. So own matter you can write. Consider a body of mass m. Okay, some force F amount of force is acted on the body. So what happened that time? So body is displaced by S displacement with acceleration A. The initial velocity of the body say u and final velocity of the body say v. Own matter you can write. Consider a body of mass m. So allowed to applying force F on this body. So that time body is displaced as, okay. So here the velocity, initial velocity is u, final velocity is v. The body is moved with acceleration A. Then the derivation from formula, from which formula will take v square minus u square equal to 2s. Highlight there. From formula v square minus u square equal to what? V square minus u square is equal to 2as formula taking. Here the equations of motion, 4 equations we know that. In that third equation I am taking v square minus u square equal to 2as. In this formula what I am doing, both the sides I am multiplying by m by 2. Both sides multiplied by m by 2. In this equation both sides multiplying by m by 2. M by 2 into v square minus u square is equal to m by 2 into 2as. Here 2 gets cancelled. M by 2 into v square. So we'll write m by 2 into v square, that is half m v square, minus m by 2 into v square, that is half m u square, is equal to ma into s. Ma into s. Ma into s. Ma I am writing in one bracket. Why? Because we know that formula F equal to ma. Here half mv square. Half mv square means we know that is final kinetic energy minus half mu square is what? That is initial kinetic energy. Here u is their initial velocity, here v is their final velocity. We know that kinetic energy formula of mv square. Final kinetic energy minus initial kinetic energy is equal to ma is what? F into s. Since I am writing F equal to what? since I am writing F equal to ma, F equal to ma. Here kinetic energy final minus kinetic energy initial is equal to W, that is work done. So why W? Here also I am writing, since W equal to what is the formula? Fs. W equal to formula is what? Fs. So this is the work energy theorem. The change in kinetic energy equal to work done. Sometimes vector form also we have to write in this. In vector form, here taking same formula, okay, from V square minus U square is equal to 2as. Here V bar minus U bar is equal to A bar dot S bar. Here same both sides multiplied by m by 2. What happened? M by 2 into V bar square minus U bar square is equal to m by 2 into 2a bar dot S bar. Here 2 gets cancelled. Half, multiply this one, half m V bar square minus half m U bar square minus here m into a bar, that we know that is ma is what? Force F bar dot S bar. Here also therefore kinetic energy final minus kinetic energy initial is equal to what? Work done W. So here also we proved the total work done is equal to what? Change in its kinetic energy. Hence work energy theorem proved. This is the work energy theorem. So next topic is their collision. After the collision topic, numericals also I'll discuss. Don't skip the video. Next question, the last, collision. The most important topic is collision. The last question, what is collision? The possible types of collisions, and explain the one-dimensional elastic collision. In this class, we detailedly will discuss about the collision. Here, the collision. Here, collision means what? A strong interaction between the two objects. So, like accidents. The strong force takes place between the bodies within fraction of seconds. The two bodies are collided. Afterwards, what happens? Sometimes the two bodies move together, and sometimes what happens that time? So they move separately. So if move separately, what type of collision? If they both with the contact they are moving, what type of collision that one? We'll discuss in this class. First of all, collision means what? A strong interaction force between the objects is called collision. There are two types of collision. One is elastic collision, another one is inelastic collision. Elastic collision means in this both momentum and kinetic energy are constant. Both momentum and kinetic energy are constant or conserved also we can say. Example, the collision between the fundamental particles. Collision between fundamental particles we can say. And inelastic collision. In inelastic collision means in this only momentum is conserved. Only momentum is conserved but not kinetic energy. Only momentum is conserved but not kinetic energy. Examples, collision between vehicles we can take. Collision between vehicles we can take. Now they are asking one-dimensional elastic collision. First, general 2-3 lines matter, own matter you can write. Consider two spheres of masses m1, m2. Two spheres of masses are what? m1, m2 moving in the same direction. The first m1 body initial velocity is what? u1. m2 body initial velocity is what? u2. Here u1 body velocity is more than u2. So then only it goes and hit the second body. Here this is before collision. You can say this is before collision. Here afterwards what happened? So u1 is moving with more than u2 speed. So what happened that time? So it goes and hit the second body, and what happened during collision? They exert their forces, they exchange their momenta and kinetic energy. Okay, so after collision what happened? Again they are limited to a same straight line. So that is why this is called one dimensional elastic collision. Before collision and after collision they are limited to a straight line. So that is called one dimensional elastic collision or head-on collision. So this is after collision. After collision final velocities are what? v1 v2. m1 body final velocity v1, m2 body final velocity v2. Okay, yeah, this is after collision. This matter, so you can write in own words. How to write? One more time I'm saying, listen here. Consider two spheres of masses m1 m2 moving in same direction with speeds m1 speed initial velocity u1 and final m2 body initial velocity u2. Okay, so here u1 velocity, m1 body velocity, initial velocity is more than m2 body velocity. So that is why the m1 sphere is going and hitting the m2 sphere. So this is before collision. Then during collision they exert their forces, and afterwards what happened? They are limited to a straight line, and m1 body velocity is v1, m2 body final velocity is what? v2. This is after collision. So this matter as it is, you can write in your own words. After writing the matter, draw the diagram, or before also you can draw the diagram. So then the derivation we have to derive. Observe here, in this we learn this is elastic collision. In elastic collision the momentum is conserved. Momentum is conserved. So that time what happened? Total momentum before is equal to total momentum after collision. So you can, I'll explain here. In elastic collision momentum is constant, momentum is conserved or constant. That meaning is what? Total momentum before collision is equal to total momentum after collision. According to that, total momentum is what? Mass into velocity. Total momentum before collision, that meaning is what? m1 u1 plus m2 u2 is equal to what? Total momentum after collision, that is m1 v1 plus m2 v2. Here left hand side m1 I am taking common. What happens? u1 minus v1, and right side m2 I am taking common, v2 minus u2. This is a equation 1. Equation 1. Next, in elastic collision kinetic energy also constant. That meaning is what? Total kinetic energy before collision equal to total kinetic energy after collision. Total kinetic energy before collision means half m1 u1 square plus half m2 u2 square is equal to what? Half m1 v1 square plus half m2 v2 square. Here left hand side half m1 I am taking common. What happens? u1 square minus v1 square. u1 square minus v1 square is equal to, here right hand side of m2 I am taking common. What happens? v2 square minus u2 square. This minus u2 square I am sending that side. Here half gets cancelled. m1 into u1 square minus v1 square. This is like a square minus b square type. So what is the formula? A square minus b square formula. A plus b into a minus b. u1 plus v1 into u1 minus v1 is equal to m2 into, here also same, a square minus b square, v2 plus u2 into v2 minus u2. This is equation 2. Equation 2 divided by equation 1. Left hand side by left hand side and right hand side by right hand side. m1 into u1 plus v1, u1 minus v1. Equation 2 left hand side divided by equation 1 left hand side, m1 into u1 minus v1 is equal to equation 2 right hand side, m2 into v2 plus u2 into V2 minus U2 by equation 2 right hand side M2 into V2 minus U2. Here M1 gets cancel and U1 minus V1 also cancel. Here M2 cancel, V2 minus U2 cancel. The remaining is what? U1 plus V1 is equal to V2 plus U2. Here U1 terms, U terms, initial velocity one side I am bringing, U1 minus U2 is equal to V2 minus V1. This is called the relative velocity of approach before collision is equal to relative velocity of separation after collision. So that sentence you have to write. What to write? The relative velocity of approach before collision is equal to relative velocity of separation after collision. This is the equation 3. After the equation 3, so next continuation part I'll discuss. The V1, V2 final velocities we have to derive now. V1, V2 final velocities we have to derive. So in this, from equation 3, so to get V1 purpose, now V2 we have to take subject. How? Here listen here. V2 is what? Okay, V2 equal to from equation 3, V2 equal to what? V2 takes subject U1 minus U2 plus V1 plus V1. This value V2 value substitute in equation 1. Equation 1 is what? Okay, in equation 1 V2 value substitute in equation 1. What is the equation 1? 1 implies V2 value substituting in equation 1. So what is the equation 1? First I'll write equation 1. What is the equation 1? M1 into U1 minus V1 is equal to M2 into V2 minus U2. This is equation 1. In this equation 1, substituting V2 value M1 into U1 minus V1 is equal to M2 into V2 minus U2. V2 is what? U1 minus U2 plus V1 and minus U2. Now open this brackets. M1 into U1 minus V1 is equal to M2 into U1, here minus U2, here also minus 2 U2 is there, minus 2 U2 plus V1. Here multiply with M1 U1 minus M1 V1 is equal to M2 U1 minus 2 M2 U2 plus M2 V1. Here what I am doing here, observe here, V1 terms one side I am bringing and the remaining terms I am sending that side. Here V1 terms, here M1 U1 is there and minus M2 U1, this plus 2 M2 U2 is equal to M2 V1 minus plus M1 V1. Okay, U1 I am taking common. What happens? M1 minus M2 plus 2 M2 into U2 is equal to, here V1 I am taking common, that is M1 plus M2. Therefore V1 equal to M1 minus M2 by M1 plus M2 into U1 plus 2 M2 by bringing this side, it divides M1 plus M2 into U2. So this is the V1 formula, the derivation of V1. So using the third equation. So like that only we have to derive the V1 V2 formula. For V2 purpose what to do? From equation 3, V1 purpose what to do? V2 we have to take in subject here. To get V2 purpose, V1 we have to take subject. V1 is equal to what happened? V2 minus U1 plus U2. This V1 value substitute in equation 1. Equation 1 implies what happens? In equation 1 I am writing M1 into U1 minus V1. So V1 is what? V1 is what? I am substituting V2 minus U1 plus U2 is equal to M2 into V2 minus U2. M1 into U1 minus V2 minus into minus plus U1 minus U2 is equal to M2 into V2 minus U2. Now M1 into U1 plus U1 to U1 minus V2 minus U2 is equal to M2 into V2 minus U2. V2 minus U2. Here open this bracket. 2 M1 U1 minus M1 V2 minus M1 U2 is equal to M2 V2 minus M2 U2. Okay, here same like that only. V2 terms one side, V1 terms one side. Here 2 M1 U1 and plus M2 U2 minus M1 U2 is equal to M2 V2 plus M1 V2. Here 2 M1 U1 plus, here U2 I am taking common, M2 minus M1. Here V2 taking common, M1 plus M2 to V2. Therefore V2 equal to 2 M1 by M1 plus M2. So sending this side, it divides 2 M1 by M1 plus M2 into U1 plus M2 minus M1 plus M2 minus M1 by M1 plus M2 into U2. So this is the V2 derivation. So these are the V1 and V2 derivations. Okay, so till here you have to write about collision. The collision attachment problem also they can ask. Okay, we'll discuss in this class. So one more, freely falling body and work energy theorem and collision attachment problems. Now I'll discuss on the first problem. You can check on screen. A machine gun fires 360 bullets per minute and each bullet travels with a velocity of 600 meters per second. If the mass of each bullet is 5 grams, find the power of the machine gun is. In this, the given number of bullets, how many bullets? 360 bullets are fired from a gun. Okay, 360 bullets are releasing per minute. So that meaning is what? N equal to number of bullet equal to 360 and time t equal to 1 minute per minute they are saying. So that is why 1 minute equal to almost 60 seconds. With what velocity they are moving? So 600 meters per second. Each bullet of mass is how much? 5 grams. You have to convert to SI. How? 5 into 10 to the power of minus 3 kilogram. So 1 gram equal to how many kilograms? 10 to the power of minus 3 kilogram. Power of the gun, how much they are asking. So what is the formula? So from power P equal to, we can take work by time. Work is nothing but energy. So here which type of energy I am taking? Kinetic energy I am taking by T. And here power P equal to, kinetic energy formula is what? Half mv square. Kinetic energy formula is what? Half mv square. Why here kinetic energy is taking? So bullet is in motion. So that is why we are taking kinetic energy taking. Here number of bullets are given. So I am multiplying with that number. So n into half mv square by t. Substitute the values. P equal to n value. How many bullets? Here 360 bullets into half into mass. Mass how much? 5 into 10 to the power of minus 3 into v square, 600 square, 600 into 600 I am taking 600 whole square by t. T is how much? 60. Okay. Here 60 1 ja 60, 10 ja 600. Here 1, 2, 3. 3 zeros purpose. Here 10 to the power of minus 3 cancel. Remaining is how much? P equal to, here 2 1 ja 2, 1 ja 2, 8 ja 16. Okay, and this 0. Now you multiply this. 18 5 ja how much? 90. 90 into 0 900. 900 into 6. 900 into 6. 9 6 ja 54 and 2 zeros. 5400 power units are what? Watts. So this one we can write in kilowatts also. Therefore power P equal to 5.4 kilowatts also we can write. 5.4 kilowatts also. So this is the final answer. Next question you can take. A pump is required to lift 600 kilograms of water per minute from a well 25 meters deep and to eject it with a speed of 50 meters per second. Calculate the power required to perform above task. In this, the from power they are lifting the water. So the mass, how much mass? 600 kg of water is lifting from how much deep? 25 meters, okay, per minute they are saying. So here time also we have to take how much? 1 minute means again 60 seconds, and with what speed? 50 meter per second. So find the power of the pump they are saying. Here the power, again power P equal to what? Work by time. Here both, so some height also there, okay, from some depth they are lifting and moving also there. Both we have to take kinetic energy plus potential energy, both we have to take by T. Here kinetic energy formula is what? Half mv square, and potential energy is what? mgh by T. Here G is what? Acceleration due to gravity not given. We have to take 9.8 meter per second square. Now substitute the values. Power P equal to 1 by 2. So here M is common. The both. So M I am taking common. How much? M I am taking common. Of V square plus GH by T. Substitute the values. M is how much? 600. And of V square is what? V is 50. 50 into 50 I am taking, plus GH 9.8 into 25 meters. 9.8 into 25 meters. Okay. Next, by time, T is how much? 60. 60 1 ja, 60 10 ja. Power P equal to 10 into, here 2 1 ja, 2 5 ja, 2 25 ja, 50. Okay. So 25 5 ja, you know that 125 and one more 0 is there, plus 9.8 into 25. If 10 is there, 10 into 25 is how much? 250. 9.8 is there, so 245 will get, by already cancel na? So 60 already cancel. Add this both. 10 into 1250 plus 245. 0 plus 5 5. Okay, 5 plus 4 9. 2 plus 2 4 and 1. 14995. That meaning is what? P equal to 14950. 14,950 power units are what? Watts. In kilowatts writing time, power P equal to 3 decimals we have to write left hand side. Why? Because 1000 divided by 1000. So that time what happened? That time 1 2 3 14.95. This 0 no need to write after decimal. 14.95 kilowatts. Some materials they'll take G value 10 they'll take, so that time 15 kilowatts they'll get, but this is a perfect answer. Why? Because G value is not given. We have to take 9.8 meter per seconds only, we have to second square only we have to take. If they'll give G 10, so then you can substitute. Okay, and next one we can check. A body freely falling from a certain height h after striking a smooth floor rebounds and rises a height h by 2. What is the coefficient of restitution between the floor and the body is? So in this collision related or collision attachment they can ask. So what they given? given will take. So a body is dropping from certain height, h height, they are saying h height. Then after striking the ground again it is rebounded. The rebounded height is say they are saying h by 2. Half of the height rebounded. So this one h1 you say h, and h2 is given h by 2. Then they are asking coefficient of restitution between the floor and the body they are asking. So formula, from formula E, coefficient of restitution E equal to, what is the formula? Under root h2 by h1. E equal to h2 is what? H by 2, and h1 is what? H is the answer. Therefore E equal to under root 1 by 2 is there, that we can write 1 by root 2. Therefore coefficient of restitution is how much? E equal to 1 by root 2. So this type of questions they are asking in attachment problems. Please focus on these attachment problems. So in the another LAQs, already part 1 LAQs are given in, so in the link I given, I provided. Okay, so part 1, now this is a part 2, part 3 another. So thermodynamics long answers are there, so that also I'll give in description, so please follow that. And I hope all are understood by easy method. So if you like this video, please share to your friends and subscribe my channel. Thank you. This is Ramana Sir Physics.